Okay, can. Video started. Can, let's begin. So this is talking about planes. Let's take a look. Let's look at point number 1, equations of a plane. So for part A, it's about the vector equation of a plane or parametric form. So I hope it's not too dark for you. For this vector equation of a plane, they show you two versions. It's really just the same thing. What you need to understand is that a plane looks something like this. It could be a parallelogram shape like this, but actually it goes in all directions, right? You understand that?
Yeah.
It's a piece of paper that goes on forever in all directions. Then what you need is a point and two directions. Two planes. Correction, two vectors that are lying on the plane, or at least parallel to the plane. So it could be floating on top like this. Oh. And that will be your M1 and M2. M2, M1. Okay?
So it's just any two different directions.
Yes, and they have to be non-parallel. Oh my goodness. What? Yes, okay. So they have to be different directions. Here should take note. M1 is not parallel to M2. Okay. Why do we need that? Because what happens when you have non-parallel M1, M2 and they are both parallel to the plane? Remember the next question. Remember the next version of the equation. This one, part B. It requires what? Just ignore this first version. Focus on the last version here. What is this guy? Just the normal. Actually, you don't even need to know that it's unit. You just need to know it's a normal vector. Okay? How do you get normal vector? Perpendicular to both. Perpendicular to the plane. How? Remember?
The cross product.
Very good, the cross product. So basically, right, this fella here will just be your two vectors M1 cross with vector M2. Can you see?
Okay.
So if it's M1 here, M2 there, and the resulting vector after you cross using right hand rule will be this vector, right?
Yeah.
That's your normal. Okay. Take note that there's also the plus lambda here and plus mu here for the first one. It's because you want to think about because you want whenever you got an equation of a plane, you're really just describing a bunch of points that are lying on the plane, and you represent each of those points by a position vector. Starting from the origin, you go towards that point, and that point will be the head of the vector, and that vector will be represented. This vector will be represented by a generic vector R. Okay, written over here. How do we get to all the points that are on the plane? You can think about it like this. You start off with the origin, and then you move towards a point on the plane, point A. Then how do you reach all the other points over there? Let's say you have another point over, let's say here, this point P, P1. How do you go from point A to point P? You just have to add on AP, AP1, right?
Yeah.
But you could also think about it like this. You can add on a copy of M2, another copy of M2, and then maybe half a copy of M2, and then you go -1 copy of M1 and another -1 copy of M1. So it's something like this will be M2, this will be M2, this will be 0.5 copies of M2, and this one will be opposite direction, so -M1, -M1. At the end of the day, what you realize is that it's really just a scalar multiple of M2, 1.5 M2, and this one is a scalar multiple of M1, so -2 copies of M1. What does that all mean? It means that in order for you to go find out what is OP1, what would it be? It will simply be OA. Hold on. It will simply be vector OA. Then you add on some scalar multiple of M1 plus some scalar multiple of M2. In this case, the scalar multiple for M1 will be -2, and for mu, it will be +1.5. Does that make sense?
Oh, yeah.
So you can repeat that procedure for any other point, P2, P3, P4, anywhere on the plane, provided you have these M2 and M1. So you just add on one scalar multiple of M1, another scalar multiple of M2. Okay, you can try with other points on your own. But basically, that's the general formula. It's basically the same as the vector equation of a line, same idea, but you add on an extra dimension. You add on an extra mu M2. Okay?
Okay.
Okay, can. Then vector equation of plane. Yeah, this one you just need to know. The generic vector R, you can dot product with the vector with the normal, and you will get some constant. Okay, and how do you find this constant? It's really just the formula on top lah, A dot n. You take any point on the plane. Let's call it point A. Then you calculate R dot with that vector. Let's just call this OA. R dot with the OA. You get some number. And then find a normal vector, usually M1 cross M2. You can make it into a unit vector by dividing by its length of that vector, but there's no need to. Just make sure it's normal. So M1, M2. Then after that, you can just combine them together. Oh, let's just denote this sum number as a D. Then together, you will get the equation of the line already. Generic vector R dot with the n that you found equals to D. Okay? Later, we'll practice some questions.
Oh, okay.
Okay, can. Next one. So, if D is equal to 0, okay, what happens when D is equal to 0? Yeah. If and only if the plane will pass through the origin. Okay, special case, plane passes through origin. Why? Because let's take a look. If you got the equation R dot n equals to D, and they tell you that this D happens to be a 0. What happens? Well, you can consider, you can sub R equals to 0, 0, 0. Then check what happens. You get 0, 0, 0 dot with vector n. And of course, that's a 0 vector. You will always get a
0.
So that, what does that mean? It means that your left-hand side equals right-hand side when you substitute in R with 0, 0, 0, which means that this vector R is a point that lies on the plane. So 0, 0, 0 does lie on the plane. I think you tried one question before on when I asked you whether a point lies on the line, right?
Yeah.
Yeah, then you have to solve and then you check that it's consistent. Left-hand side is equal right-hand side. So it's the same idea here. It's just that now it's asking whether a point lies on the plane. So all you do is to substitute the the position vector of that point into the equation of the not line but the plane. And check that left-hand side equal right-hand side. Okay.
So this means that it lies on the plane. Okay.
Correct. You can also, if you want to check other points, you just sub in, like, for example, if you want to check whether 1, 2, 3 lies on the plane, you just sub in 1, 2, 3 here and check whether it's equal to the right-hand side, the D value. Here, the notes, I'm just telling you the special case when D is 0. It will pass through origin, just FYI. All right, next bullet point. If the plane is parallel to the two vectors B and C, then B cross C is N. I think I mentioned this already, right? Yeah. Parallel to the vector. Maybe I just draw a picture. There's a vector B, there's a vector C. Then the resulting vector will be B cross C, which is your normal. Okay, can. Next one, Cartesian equation. Basically, you rewrite it as X, Y, and Z. Here, it's quite simple. All you need to do is to start off with, I would prefer starting off with the scalar product form. Then you substitute vector R with X, Y, Z. Just like your equation of a line, right? Substitute the vector R with X, Y, Z. Then after that, you can just solve for X. Then you can get three equations. Get three equations involving X, Y, and Z. Sorry, is it a bit difficult to see pink color?
Can.
Should I change it to black? Blue. I think black. Okay lah. Yeah. I'll send it to you later. Okay, then for point 2, ignore the scissors. Point of intersection of a line and a plane. Technically, in your syllabus, right, they removed it they removed this particular line. This particular statement about finding out the point of intersection of a line and a plane. However, it has still been tested. It has still been tested because, okay, I'll just show you the syllabus again now. Okay, over here, do you notice this point 2? Relationship between a line and a plane?
Yeah.
So implicitly, they are asking you to find out all of the relationships between a line and a plane, including finding out the point of intersection. So if you looked at the old syllabus, the old syllabus was 9740. They included one extra line that said, okay, find the point of intersection between a line and a plane. But now they removed it.
Oh.
But I do not think it is removed because I checked the 10-year series already. It is still part of this part 1. Sorry, part 2. It is still included in part 2. A line and a plane relationship. What kind of relationship? Plane, a line that cuts through. Plane, a line that is parallel. What else? That's about it. Right? So so this one still need to know. So please ignore the scissors. The scissors there, I took it from some book. They say cut away from syllabus, but actually it's still there. Okay, so how do you find the point of intersection between a line and a plane? It's very simple. You already know how to find point of intersection between two lines, right?
Yeah.
You got R equals something, just equate them. Here it's the same thing. You got equation of a line, you got equation of a plane in scalar product form. Then all you need to do is to substitute. You see R, substitute the A plus lambda D inside the R. Okay, then you get this A plus lambda D dot with N equal to P. Is that clear?
Can.
Then after that, you just need to solve for lambda. Exact same procedure as the vector equation of a line. After solving for lambda, what can you do? You can substitute it back inside here, the equation of a line. Then you'll get your R here to be the point of intersection, the position vector of the point of intersection. Can? Can. I will just practice questions and it will be clearer. Okay. Now, next one, acute angle between two planes. Here you have to be creative. Let me draw a picture for you. You know what? Never mind. I draw a picture later. Here is pi 1. This is pi 1. That's how we represent a plane. We put down the symbol pi 1. Sometimes we also put down P1. Then we put a colon. Then followed by the equation. Okay, so first one is R dot N1 equal to P1, R dot N2 equal to P2. So two different planes. Then you want to find the angle between two planes, you need to realize that it's actually just the angle between the two normals of the plane. Then all you need to do, how to find angle between two vectors. Normal is just a vector, right? Just use the formula again, cosine theta, dot product. And you put modulus when you want to find acute angle. Okay, acute, modulus here. Modulus, ensure positive. So that when you take the cosine inverse later, you don't have to care about, is it quadrant 1, quadrant 2, quadrant 3, quadrant 4, ASTC? Don't need. ASTC, it will always, after you modulus, it will always be quadrant 1. Oh, acute angle. Okay. Actually, A here stands for all, not acute. Okay, Ken, let me show you a picture. Acute angle between two planes. Let me find a picture from the more long-winded version of the notes here. If I can just find it first. Here, beautiful picture. Okay, can you see a blue color plane here and a green color plane?
Yeah.
Then these two blue lines are just for reference. But what's more important is that now we got a normal N2 and we have a normal N1. Can see?
Okay.
So what you notice, the angle between the two planes is actually this angle here. However, it's really just the same as the angle over here, which is the angle between the normal. Are you convinced?
Sure. Yeah.
Yes, then that's a rule. So now whenever you want to find angle between the plane, it's the same as finding out this angle here, which is the angle between the normals. Okay?
Okay.
Can yeah, you can scroll through and look through again, but this is the main point. I want the picture. Okay, go back to the summary on the top. If you know time, don't bother reading the long-winded version. Just use the short version can already. Point number 4, acute angle between a line and a plane. Here there's a picture. Please ignore my finger. So you got a line here represented by this vector equation, a plane here represented by this scalar product form. You want to find the angle between the line and the plane, you must draw a picture. Please, 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 please. Draw a picture. You don't just memorize formula, draw a picture. Here, plane. Here is a line cut through. If you really wanted to, you can think of it like it will be dotted because it's underneath the paper, and then it's solid line because it pops out from the paper. Okay?
Okay.
Yeah, but don't need to if you don't want. Okay, I'll just leave. I think I'll just erase it. Okay, so what you need to realize is that you're trying to find this angle here. Correct or not?
Yeah.
Then this angle here, do you realize that actually it is very difficult to find this angle? So what we do is we get creative and we try to find out this angle instead. We focus on this angle. You agree that it's 90 minus theta?
Yeah.
Right, because here's a right angle triangle. So that means we now have this angle that is sandwiched in between this line and this line. Agree or not?
Yeah.
Can you tell me what's how do you find the angle here between these two lines? This line.
The cosine of the two vectors.
Yes, cosine theta formula, right? Which involves dot product or cross product?
Dot product.
Dot product, exactly. But using the line itself, not so smart. You should use the direction vector, right?
Yeah.
Then this line itself is a normal, also not so smart. You take the normal vector. So at the end of the day, all you need to do is to find use the cosine theta formula for the direction vector of the line and the normal of the plane. Does that make sense?
Yeah.
Can okay, so that's exactly what we have here. But how come here is sine theta? Why is it not cosine? This one. Because we are now not focusing on, because you must remember your goal is to find theta. Here we are finding 90 minus theta indirectly, which indirectly helps us to find theta. Okay? So actually here it's cosine of the 90 minus theta. Okay, if you use the cosine formula, you will be able to find your 90 minus theta, but you must draw a picture to help you understand that you're finding out this angle at the top, this angle here, which is not answering the question directly. It's just indirectly helping us to find out theta. So you need to do a bit of algebra to find out theta. Alternative strategy, instead of memorizing sine theta, which is what I usually do, I draw a picture, I use cosine formula, I memorize cosine formula only. Then after I find out, so for example, if let's say this angle here, after I use my cosine theta formula, I find out that theta is 23 degrees. What I do is I use the picture, then I take 180 minus 23 minus 90. Obvious, right? Here 23, here 90, and find the last angle. In your prelim paper, ASRJC, I did the same thing, but with radians. I did pi minus some pi by 3 minus away something else. Minus away 90 degrees, which is pi by 2. Something like that. You can go check the working. Okay, then yeah, you can get the final answer. Alternatively, if you really like to memorize, then memorize that it's a sine theta law, which is a bit funny.
Yeah.
I prefer memorizing fewer things and just draw a picture. A picture is very easy to draw. Just need to spend a bit of time. Draw a line, draw a 90-degree triangle, so on and so forth. Can?
Can.
Okay, next one, number 5, parallel or perpendicular lines. So again, you got equation of two planes, r dot n1 equal to p1, r dot n2 equal to p2. Pi 1 and pi 2, they are parallel. Then they tell you that it's equivalent to the normals being parallel. Does that make sense?
Yeah.
Okay, draw a picture, draw a picture. This one, if you can make sense in your head, not such a good idea. You should still draw a picture. Not such a good idea to leave it in your head. You should always draw a picture. Okay, here is a picture. Okay, so relationship between two planes. Okay, first I talk about part A, parallel. So can you see parallel planes?
Yeah.
Pi 1, pi 2. Then can you see the normal vectors? Green color?
Yeah.
I think it's quite obvious they're parallel, Okay, convince, draw a picture. Always draw a picture to convince yourself. Okay, let's go back. Go back to the summary notes again. That was about parallel planes. Now we move to the next point, which is about perpendicular planes. Okay, if they are perpendicular, it means that the n1, n2 are perpendicular. Okay, this one I don't have a picture, so let me just draw one over here. Wait out. Test my art skills. Let's say that the planes are made of glass, so I will draw solid lines through them. Made of glass, made of glass. Something like that. So what you notice is that they are now perpendicular, which is what the question started off with. So I'll draw 90 degrees like this. And what you realize is that you can draw a normal. Let's say from this plane, you draw a normal like this. N1. Then on the floor, you got this other plane. It also has a normal like this. Are you convinced now that they are 90 degrees?
Yeah.
So they are the same. And what do you know about 90 degree vectors?
The dot product is 0.
Very good. Dot product is 0. Okay. Can I just request for a 5-minute break?
Sure.
In the meanwhile, could you help me to try this paper, the homework 2, involving dot product, cross product?
Oh, they are quite hard. I tried to do no cannot.
Oh, try already. Okay. I think before I go on, maybe it's better if I go through that worksheet first, because those are the application questions. Then it may still come up. Before I go on to talk more about planes.
Okay.
The next part will be about the what do you call that? Homework, actual questions that will come up involving planes.
Okay.
Usual questions.
Okay.
But let's have a short 5-minute break because I need to use the toilet.
Sure.
I'm gonna resume. Oh my goodness. Okay. I hope you sort of caught what I was saying for the previous part. I forgot to record.
I go right down.
Yeah, I will send you the PDF also. So it's all right. This one is just algebra. You take the dot product, but for 2D vectors, and there are 2 different values of p because there's 2 possible angles, either anti-clockwise or clockwise. You get 2 possible values for p. The coordinates of p. This one I will get back to you. Question 1, part 2. Then question 2. Question 2, I also went through with you. It's the application of. Okay, part 1 is not likely to come out, but part 2 is more likely. Part 2 is just testing you on how to use the area of triangle formula. Then you take the cross product. And they're also testing you on the fact that P cross with P is 0 vector, so you can simplify things a lot. Likewise, when you take the modulus of another rule they test you on is Q cross P is the same as negative P cross Q, but when you take the modulus, the negative will just disappear, essentially. You factor it out, you get modulus -1, modulus P cross Q, but the modulus of -1 is just a +1, so you get +1 multiplied by modulus of P cross Q, which is just modulus P cross Q. And you can also factor out scalars, term by term. All right, can yeah, all right, then let's just continue. This one just use the cosine formula to find the angle. Where was I? Question 5. Oh no, question 5 went through already. Parallelogram proof. Rhombus. You want to prove that the diagonals are perpendicular as well as the cosine rule. You can go read the solution again now. Okay, let's move on. Let's continue. So here, what we have is a reinterpretation of the triangle of the vector OP. So we rewrite it like this. We get the ratio 1 minus k and k. Then what we realize is that we want to find out BP square. So it's a good idea to find out what is vector BP first. Then later we find out BP square, which happens to be modulus of BP square, which is really just the same as BP dot with BP. It's a special identity. All same vectors. So sorry, I should put a vector notation. Dot product in between. So now what we want to do is to find out vector BP first. And what we realize is that vector BP is just the ratio BP over BA multiplied by the vector BA. So what we realize is that BP over BA is just K divided by 1, so it's a K. Then BA is just BA. So far, so clear?
Yeah.
So far, so good? Okay, good. Wait, let me get the battery. Okay, yeah, so anyways, BP is equal to K times BA. So that means if we take the dot product, we get KBA dot with KBA. But what happens when we take the dot product of 2 same vectors? It will just be the modulus square. Same vectors, I went through it. on Wednesday. Then you can just take the dot product of these guys. The scalar can multiply k dot with k. It's just k square lah. Then BA dot BA. Can?
Can.
Okay, good. But wait, what's BA?
It's
How can we
modulo.
break? No. What's vector BA? Yes, it's modulus BA square, but there's another more subtle point. Vector BA itself can be broken down into two things. What minus what?
OA minus OB.
Very good. So that's what we're going to do. We're going to split it up. OA minus OB, OA minus OB. Yes, you're correct. It can be equal to BA square modulus, but that's not useful to us. We are going to split it up instead.
Okay.
So OA minus OB, it's really just A minus B, A minus B. Then now you can expand, you can distribute. So what you'll get is, eventually, let's just distribute it step by step. A dot with A dot A. A dot with negative B, negative A dot B. Negative B dot with A, negative B dot A. Negative B dot with negative B, positive B dot B, right? Negative and negative gives you positive.
Yeah.
Yes. Okay, then now we simplify. A dot B here and B dot A here are the same. So that's why, right? Because A dot B is the same as B dot A. So that's why we will simplify them into, I'll just rewrite this B dot A as A dot B. Can?
Can.
Then after that, you got two copies of the same thing, subtract. You're left with minus 2AB dot B. Okay?
Okay.
But modulus A square, okay, that's not important. Just leave it as length A square and length B square. Notice that I never put vector here. Oh, by the way, it is wrong to write down vector square. This is wrong.
Oh, must be modulus.
Yes, correct. If you're trying to square, because it does not make sense to square a vector. There is no operation of squaring a vector. There's only dot product or cross product. No such thing as squaring a vector.
Oh.
Sorry, I shouldn't draw in the pink line. Modulus A square is okay. Okay, modulus A is a number square. Like for example, 3 square, 4 square, 7 square. That kind of number, that kind of math notation makes sense. Okay, but anyways, what we get at the end of the day is k square multiplied by bracket a square minus 2a dot b plus b square. Is this part okay?
Yeah.
Okay, this one is vector. So let's take a look. Is that what we wanted to show? Yes, that's exactly what we wanted to show. Okay?
Yeah.
Can? So that's for BP square. Not done yet. Still need to deduce similar expression for AP square and OP square. How? So let's see. Same thing here. AP is just a fraction of AB. So AP over AB is actually just 1 minus k over 1. So it's 1 minus k. Then what does that mean? It means that vector AP is just 1 minus k over 1 times vector AB. Okay?
Okay.
Then we do the same trick. Take the dot product. It's really just the modulus square, which is just the length square. And then that's on the left-hand side. But on the right-hand side, we got 1 minus k AB. That's the first vector. You take the dot product with itself. So it will be 1 minus. So this will be 1 minus k AB dot product with 1 minus k AB. The scalar 1 minus k will multiply by each other to give you 1 minus k square. The AB will dot product with itself to get AB dot AB. Is that clear?
Yeah.
Okay, then again, same trick. I know that AB dot AB is the same as modulus AB square. But it's not useful. Okay, sorry. It's true, but it's not useful. A lot of times you'll see in math, things are equal, but it's not useful. I know 1 plus 1 is equal to 2, but that's not useful to me. Okay, so AB is OB minus OA. AB is also OB minus OA. I can substitute 2 times. Okay, then I replace it with B minus A and B minus A. Maybe I zoom in. Yeah. So now what I can realize is that I can factor out a negative 1 from each of them. So I'll get a yellow color negative here and there. Multiplying the negative, I get positive, right?
Yeah.
Okay, good. So now I'm left with A minus B dot with A minus B with brackets. Again, you expand and simplify. It's the same working as before. Skip many steps. I just recycle the working. Notice the purple color highlighting? They are the same.
Yeah.
So I just recycle. Can save some time. I get A square minus 2 vector A dot with vector B plus B square. Notice that the A here and the B here, they are not vectors. They are lengths. the length of this guy and the length of that guy is A and B respectively. A, B. Can? Can okay, that's for AP square. Can you try? Do you want to try on your own similar expression for OP square?
Oh, okay.
Okay, I give you 1 minute. Go. Hint is vector OP is K times of OA plus 1 minus K times of OB. Can try for, I give you 1 minute to try, then I go through already. Okay, give a hint. OP square is what? OP square is at the bottom. Just take the dot product of itself. Did you do that?
Yeah, I did that.
Then you distribute. Okay, give you another 30 seconds. Okay, due to time constraint, I'm gonna go through already.
Okay.
Can also what happens if you expand it? Here is what happens. You eventually get to, I'll just show you. First, I simplify the vector OA and vector OB as vector A and vector B. Then I expand. KA times KA, K square times modulus A square. Remember, this one is actually A dot A, but it's a special identity. A dot A is just modulus A square. Likewise, for B dot B, it's modulus of B square. Because of cosine 0 degrees, it's just 1. When the vectors are the same, the angle between them, the theta, is 0 degrees. So cosine 0 degrees is 1. So you get mod A mod B cosine 0, which is mod A mod B times 1. So it's just mod A mod B. But in this case, A and B are the same, so it just becomes modulus of the same thing square. Okay, now this one?
Okay.
Then you do the same thing. So you need to make use of those identities. Let's just expand it. Ka times Ka, K square modulus A square. Ka times 1 minus K vector B. K times 1 minus K remains outside, A dot B. Next one, 1 minus K dot with K dot A, scalar remains there. So K times 1 minus K, don't need to expand. Then B dot with vector A. But you realize that it's the same as equivalent to A dot B, identical. Next one, 1 minus KB multiplied by 1 minus KB. It becomes 1 minus K square times modulus of B square. Okay, that's good. But we can simplify further. Since these two guys, the factor are the same, K times 1 minus K and K times 1 minus K. And these two guys, A dot B, are the same. That means that these are actually two like terms. Like terms means you can add them together, 2 copies of them, 2 copies of K times 1 minus K, A dot B, plus the last remaining term. Okay? Okay, that's the expression. Since they never specify what exactly you need it to be, this is similar expression. I think this is good enough. Let us move on. So now we realize that So let us move on. What the question now wants us to do is that they want us to take K to be equal to half. And then you deduce OA square plus OB square is 2OP square plus 2AP square. So you have to substitute K with half. That's what we're going to do. here, I start off with the right-hand side. I want to show that it's equal to the left-hand side. Oh, the question is over here. Then what I do is I just write down the right-hand side and then I substitute OP square and AP square with what we just found previously. You can go and check afterwards that I copied correctly. You can go and check later. I'll send you the PDF. So basically, this is OP square, that's AP square. We found out previously. Okay? Okay, then what we realize is that they want us to have k equal to half. So I just substitute with half and I simplify. Everywhere that had a k, I replace with half. So k square becomes half square 1/4. 2 times k times 1 minus k. I just rewrite it as 2 times half times 1 minus half. Multiply out and I get a single 1/2. Then here 1 minus k square becomes 1 minus half, which is just a half. Then you square the half, you get a 1/4 over here. Continuing on, we also get something similar with the 1 minus k square. You get half square, which is 1/4. This part okay?
Yeah.
Can Okay, good. Next, we continue to simplify. We multiply the two in. And also take note that here is actually 2 times 1/4, so it's just 1/2. Then I just simplify as 1/2 first. Here 2 times 1/4 becomes a half. 2 times a half becomes a 1. So I never put down a 1 here. 2 times a 1/4 becomes a 1/2. And yeah, I also replace my modulus A with just a single A, modulus B with just a single B. Okay. Okay, so that's what I get as a result. I multiply in the half. So I get a half A square minus half times 2, which is just minus 1 of A dot B, and half times B square. Then I realize that A dot B can cancel off. Notice that? Plus and minus. So I cancel them off. And I realize that I blue highlight and yellow highlight. What does it mean? It means they are like terms. Half A square plus half A square becomes a single A square. Likewise with the yellow. Half B square plus half B square, single B square. So it becomes OA square plus OB square. Okay? Then that's the answer already. We get the left-hand side shown. Does that make sense?
Yeah.
Okay, so yeah, that's just a special identity. It's from geometry, but honestly, not that important. Okay, Ken? That's question 7 done. Very difficult. Let's move on. Let's move on to question 8. So I still got 3 more questions. Oh my goodness, I haven't talked about planes. Okay, question 8. Let's take a look. Refer to an origin O. Points A and B have position vectors given respectively by this fella and that fella. The point P is on the AB such that AP is to PB has a ratio of lambda is to 1 minus lambda. You want to show that the resulting vector OP follows this particular vector. So what rule do you think you want to use? You see O, A, B, and then a P that's
the ratio theorem.
Very good. Yes, exactly. That's exactly what we are going to do. Ratio theorem. I'll paste the question over here for reference. Yeah, that's exactly what we're going to do. First, you draw the triangle. Then you label point A, point B, and a P in between. Ratio is lambda is to 1 minus lambda. Okay? You want to show that OP is 1 plus lambda, 2 minus 5 lambda, minus 2 plus 8 lambda. Okay? I'm going to show this. Can? Yeah, so we're also given that vector OA is 1, 2, minus 2, and OB is 2, minus 3, 6. You know how to convert, right? From the IJK notation.
Yeah, can.
Good. Then by ratio theorem, just draw your dark bone here. OP is equal to 1 minus lambda times of OA and lambda times of OB. You add them together. Divide by the sum, which is 1 minus lambda plus lambda. What do you realize about this denominator? It becomes a
1.
A 1. Divide by 1 means?
Just like the number.
Just the numerator. Like 5 over 1 is just the number 1. Just the number 5. Okay, good. So that's what we have, the numerator. And I write down over 1 just to emphasize to you that it's a 1. Then after that, I simplify already. Just the numerator. But I also replace the OA and OB with 1, 2, minus 2, and 2, minus 3, 6, which I get over here. I think this part should be easy, right? You just multiply in. Then I add them together, and then it's shown. Done. Question 8 is quite easy.
Okay.
You can verify on your own. Okay, good. Question 8 done. Let's move on. Question 9. Let's go to question 9. Wow. Okay. Question 9 and 10 also quite long-winded. Okay, let's go. If I can find the question first. Yeah, so here is question 9. You got a position vector A and B with respect to an origin O, represented by little a and little b respectively. Show that for all values of the real constant lambda, the point P with position vector P is given by P equals to lambda vector A plus 1 minus lambda vector B is collinear with A and B. What that really means is that your point P is on the same line as AB but produced. AB produced to point P. Oh, it's this diagram. A, B, then extend it all the way to point P along the same line, along the same direction. Can?
AB produced to point P is AP.
No. Sorry. AP produced to point P is just an extension of AB along the same direction. Extend along the same direction. Okay. A towards B is this direction. You continue in the direction until you reach point P. That's what we mean by AB produced to point P. Okay. Then moving on, we want to show what? You want to show that this point P is collinear. Okay, collinear. So how do you show collinear? You can maybe find out a vector AB, find out a vector AP, and show that they are parallel. Is that clear?
Yeah.
Okay, so we're gonna do that. So vector AB is OB minus OA, so B minus A. And we're also given that vector P is lambda A plus 1 minus lambda B. Let's keep that in mind. Then AP, it will be OP minus OA, which is P minus A. But we know what's vector P. It's just this guy. So we substitute in. Then we get this minus A. Combining like terms, I see vector A, I see vector A. I see lambda and I see a negative 1. So it simplifies into a lambda minus 1 times of vector A plus 1 minus lambda B. This part okay?
Yeah.
Okay, then I can simplify a bit more. I realize that lambda minus 1 and 1 minus lambda, they look very similar. They're just off by a negative 1. So that's what I do. I factor out negative 1 from here. I get negative of 1 minus lambda times vector A plus 1 minus lambda times vector B. Both are 1 minus lambda highlighted in yellow. Then I factor out the 1 minus lambda. I get 1 minus lambda, bracket negative A plus B. Simplify is B minus A. Okay?
Okay.
But wait, what's B minus A?
The AB.
It was vector AB. So that means that this is actually 1 minus lambda times of vector AB. We have just shown that AP is equal to some scalar multiple of AB, where this K here is 1 minus lambda.
Oh.
What does that mean? They are collinear, that's all. ABP are collinear. And we show this in general. The lambda didn't have to be a specific number. So that means that lambda works for all real values. Every possible real number lambda works, which is what was requested by the question. Okay. Yeah, they requested for all over here for all values of the real constant lambda. Means you don't go and guess what is the lambda value. You don't solve for lambda. You just use lambda as lambda itself. Okay. Okay, good. That is part. That's the first part. Part 0, they didn't even specify the part. Now is part A. Show that the point Q with position vector Q given by 3A minus 2B lies on BA produced. Find the ratio QA is to QB. So BA produced means what? So we have to draw the diagram. Here I go and redraw the diagram a little bit. So imagine you have a line. Imagine you have vector OA and vector OB represented by a blue vector and an orange vector. They tell us that the OR, I think that's what they name it, vector OR, which is just a little r. They tell us that it's 3A plus 5B. So here's the diagram. A, you take 3 copies, 1, 2, 3. B, you take 5 copies, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you end up over here. Then this resulting pink color vector is vector OR, or just little r, 3a plus 5b. What did the question say? Let's read the question. Let's read the question. The question part A says that show that the point Q given by blah blah lies on BA produced. Oh, sorry. I was looking at part B already. Sorry, please unwind by 3 minutes. I should start from part A. I'm so sorry. Let me think a bit. What am I doing? Okay. Show that the point Q with position vector Q given by Q equal to 3a minus 2b lies on BA produced. Then find the ratio of QA is to AB. I just realized that I didn't answer part A. Okay, hold on a second. Right. I misread the question. Oh. Sorry. Here, this is not the answer to 9 part A, it's 9 part question mark. This is the first part. This is called part question mark. And then now I have yet to answer part A. Let me try and solve question part A now.
Okay.
Yeah, sorry, I didn't see that. Okay, so let's answer question 9 part A. Question 9 part A tells us that you have a point Q with position vector Q given by, which is really just OQ, given by 3a minus 2b. You want to show that it lies on BA produced. Then you want to find the ratio of QA is to AB. So what this means is that you have point A, point B, or maybe if I just swap them around to make my life easier, point B here, point A here, and then BA produced. So BA produced until Q. Is that okay?
Yeah.
Can Yeah, then they tell us that they ask us to find out what is the ratio of QA is to AB. So that's our goal. We want to find out that ratio. I think it's clear that we have a triangle like this, right?
Yeah.
Then you have to use what theorem? Ratio theorem, huh? So let's do that. So let's just call the ratio here T and U lah. Okay, so that means that we need to find out what is T, find out what is U. So let's do that. So vector OA is actually just T times of vector OQ plus U times of vector OB. Divide by T plus U. Can? Can, huh? Actually, sorry, I realized I didn't do the front part first. This is under the assumption that Q is produced from BA. I need to actually prove it first. Yeah, I need to prove it, right? That's the first part. Show that the point Q with position vector Q lies on BA produced. So this is for the second part of part A. The first part of part A is to prove. Sorry. Okay. So let's figure out what's AB first. AB is really just OB minus OA, which is B minus A. Yes?
Yeah.
Okay. Then what do we have for OQ? OQ is 3a minus 2b. So what does that mean? It means that we can rewrite this as, okay, if we want to show that Q is collinear, maybe it's better if we find out what is BQ. BQ. Let's find out what's BQ. Yeah. And in fact, it would be smarter if we work with BA, so that they're in the same direction. So this is just negative A plus B. No. Negative B plus A. Is that okay? Just multiply by -1?
Yeah.
Can I work with BA? Because I noticed this is the picture we need to have eventually. BA is in this direction, BQ will be in the same direction. Then we don't have to worry about negative sign. So let's focus on BQ now. It will just be OQ minus OB. But we know what's OQ, right? What's OQ?
The 3A minus 2B.
Let's do that. 3A minus 2B. Then we just subtract the B. So we get 3A minus 3B. Is that okay?
Yeah.
Okay, then wait, this one maybe it's better if I rewrite as A minus B. I think it's obvious now. How to show collinear? BA and BQ, we need to show that they are parallel.
Multiple. Oh.
Multiple. Yes, that's the same as parallel. So what you realize is you can factor a 3 here, which is 3 times of bracket A minus B. But what's A minus B? It's vector BA. So it's 3 times of vector BA. Can?
Can.
So therefore we show that Q is collinear with A, B. Points A and points B. Points A and B. Okay, and then finally, after we have shown this, we can use the diagram and answer the second part of the question. Okay. Sorry, I didn't catch that. You need to prove things first before you can use things. So we have proven that the Q, this picture is actually true. The Q is produced from BA. Then we can use ratio theorem. Okay? Yeah. You need to provide your evidence before you can quote your theorem. So that's what we do. Okay, fine. But then how to continue? How to continue? QA is to QB. Actually, maybe ratio theorem using two unknowns T and U is a bit difficult. So I'm gonna toss this aside. I don't want to use it.
Oh.
Instead, I'm gonna use another way, which is, they just want us to find out what is QA is to QB.
Yeah.
Which I find out as T is to U, but I think maybe it's not that useful. Actually, QA is just essentially just the length of vector QA, right?
Yeah.
Then can we find out what is QA? Yes, it's OA minus OQ. But do we know what is OA and what's OQ? Not really. We only know it's vector A and OQ. Maybe we know a bit more. It's 3A minus 2B with bracket. With brackets. By the way, did you know that every time you see a negative sign, there's an invisible pair of brackets?
No.
Like for example, A power M divided by A power N is A power M minus N. So what is A power 3x over A power 1 plus x? What is it equal to? A power what?
3x minus bracket 1 plus x.
Close bracket, right? If you never put a bracket, it will be wrong, because you need to distribute the minus. Does it make sense? So actually here, minus n, there's actually an invisible pair of brackets. You already know this from O levels. It's the same thing. Math notation is very funny. It's always an invisible pair of brackets, but we don't write it down. Okay, invisible pair of brackets after the minus sign. So yeah, that's what we do. So modulus of what? A minus 3A plus 2B. Simplifying, we get, let's see, minus 2A plus 2B, right? But wait a minute, we can simplify this a bit more. Notice there's a factor of 2, right? So we can factor it out. So we're gonna factor out the 2. So we are left with 2 multiplied by modulus of, can you tell me what is it?
Modulus?
I take out a 2.
Oh, it's negative A plus B.
Yes, okay, good. So that is your QA. But QA is not done yet. We still need to find QB. How? QB is actually just the modulus of vector QB, right?
Yeah.
So let's just shrink it down a bit.
So it's OB minus OQ.
Yes, correct. You got it. So it's OB minus OQ, which is really just B minus away OQ. Bracket. Distribute the negative sign. I will be able to get B minus 3A plus 2B. But B plus 2B is 3B. minus 3a. Can?
Can.
I factor out something. What can I factor out?
The 3.
Factor out the 3. You're left with 3 times modulus b minus a. So that is your QB. At the end, oh, by the way, this one is just 2 times if I just swap them around b minus a. I think by now you should know the ratio, right? So what is QA is to QB?
It's 2 to 3.
Exactly, that's all, right? So if you really want to present it formally, you can write down, wow, no space. Wait, just gonna move this here. Ratio theorem, bye-bye, don't need it. Wow, this is, delete. This is extra. This is ratio theorem. And then I'll just move a comment, not useful. I'll move my working.
Got 2 unknowns, so I try not to use.
Correct. Yes. Very difficult if you got 2 unknowns.
Okay.
So yeah, just QA over QB, you could just put down a 2 times modulus b minus a over 3 times modulus b minus a. Then the modulus is just a scalar, so you can cancel them off. You're left with 2 over 3, which implies QA is to QB is to 2 is to 3. This working is not necessary. Don't need a bit extra. I think it's quite obvious. You see 2, you see 3, and then you see the common factor. Yeah, it's just 2 is to 3. Okay. Can. Good. That was part A only. Then part B. Part B is when we have to actually draw the funny diagram. Let me just copy the question down. This is 9 part B over here. Wow, very small. Okay, let's read the question. Point R, it has a position vector R given by R equal to 3a plus 5b. So that's what I do here. I figure out the vector 3a plus 5b. This part okay, right?
Yeah.
3 copies of the blue one, 5 copies of the orange one. So now I get then now I want to find the position vector of the point where OR meets AB. What this means is here is OR. There is AB. Do you see the point of intersection Q?
Yeah.
Okay, maybe I shouldn't have used the point Q lah, huh? Wow, but it's a bit too late. Okay, because I didn't realize that there was a part A that used point Q. They are not related. They are not related. Part A is not related to part B. So this Q is not related to Q in part A. Oh, not related. It's a totally new question. Okay, so now you got a point Q here. You want to, what do they want you to find? Find the position vector of OQ. So in other words, this is just asking you to find OQ. That's our goal. All right, so how do we do that? Let's take a look. What you realize is that it's a point of intersection between 2 lines. So doesn't it make sense if we find the vector equation of the 2 lines and then we just do simultaneous equation?
Yeah.
Can, right? Substitute, then we can solve for the point of intersection. So that's exactly what we do. We find out the line AB. What would it be equal to? You need a generic vector R, you need a specific point on the line, plus some scalar multiple of a direction vector. AB, can take AB. And I just picked point A. I could have picked point B as well, or vector B. Same. So simplifying, I get R equal to A plus S multiplied by bracket B minus A. I just picked S because I like S. Okay, then then I like the letter S. Then the other letter you could pick is letter T. So you can find out the length of line OR. Then this will be what? Just a generic vector R equals to a point that's on the line. Here in this case, it passes through the origin, so I pick the 0 vector. Here, if you are fast enough, you don't need to write this down. Oh, because you add on 0 vector, it doesn't do anything. Is that clear?
Yeah.
But now you have the remaining part, so t times of the direction vector. Here, t is just an arbitrary variable, it doesn't matter. You could have picked lambda and mu, it doesn't matter. Any letter. Then the direction vector here, that's the main point, 3a plus 5b. How do you get 3a plus 5b? It's because of this vector here. Line OR is parallel to itself. Does it make sense?
Yeah.
Okay, so you're parallel to yourself, so that's why you can put down 3a plus 5b. Okay, good. So simplifying, we get r equal to t times bracket 3a plus 5b. This is equation 1, this is equation 2. Can?
Can.
Okay, so now that you got r equals, we want to find point of intersection. What should you do? Equate them. 1 equals to 2. So now we can solve. You got a plus sb minus a. Put that there. You got t plus 3a plus 5b. Put that over there. Equate them together. Is it okay?
Yeah.
So now if you go back to okay, let's just simplify first. What I realize is I can expand the s. So I go into b and go into minus a. I get a plus sb minus sa. And then I factor out vector a. So I get 1 minus s times vector a plus s times vector b. Is that okay?
Yeah.
Okay, same thing over here. You can multiply the t in. So you get 3t times vector a plus 5t times vector b. Now, equating the coefficient. This one I mentioned before briefly in the notes. Let me just show you. Over here, if you got a and b, they are non-zero vectors and non-parallel vectors. And I should for part B, if you got alpha a plus beta b equals to lambda a plus mu b, you can just equate the coefficient. Does that make sense?
Yeah.
Can alpha go with lambda, beta go with mu. So same thing over here. I also equate coefficient. That's why I get 1 minus s equals to 3t. That's my first equation. S equals to 5. That's my 5t, sorry. That's my second equation. Or equation 3, equation 4. This part okay?
Yeah.
Then you just do simultaneous equation, solve for s, solve for t. Blah, blah, blah. I get t equals to 1 over 8. S equals to 5 over 8. I'm going to skip this. I think you should know how to do this. And so after I solve for t and solve for s, actually you don't need to solve for both. You just need one of them. Let's say I use t equal 1 over 8. So that's what I do here. I substitute t equals 1 over 8 into, I don't know, equation 1 or 2, doesn't matter. I just pick equation 2 arbitrarily because I see t here. Okay, so that means I'll get 1 over 8 multiplied by 3a plus 5b. Simplify, I get 3 over 8a plus 5b, and that is my answer. So of course you can also do the alternative, which is to use the value of s 5 over 8, and then you substitute into equation 1. Let me zoom out a bit so I can see the whole thing. So s equal 5 over 8, you substitute into equation 1 here. What will you get? You get a plus 5 over 8 times b minus a, multiply out the 5 over 8, and combine the like terms. So 1a minus 5 over 8b, 5 over 8a, you get 3 over 8a. 5 over 8b remains, and you get the same answer. It's an alternative. Can?
Can.
Yeah, good. Okay, so that is this question. For part B, we are not done yet. Still got part C. Let's move on. Super long-winded question. Let's move on to part C. Let's take a look. So part C, you want to prove that the value of lambda for which OP and AB are perpendicular is given by this formula. Can you tell me straight away, when you hear perpendicular, what do you think of? What formula?
Cross product.
Ah.
Oh, but here got the dot, so it's dot product.
Yes. What's so special about dot product of perpendicular vectors?
Like it will become 0.
Very good. That's exactly what you need to have in your mind. Straight away, a dot b equals 0. If you don't have this in your mind, this question you cannot do already. Bye-bye already. That's your first step. A dot b equals 0. Okay, process. Not process. Prove that the value of lambda for which OP and AB are perpendicular is given by the following formula. They talk about OP and AB being perpendicular, so straight away you want to look at vector OP and vector AB dot product equals to kosong, 0. Can?
Can.
Okay, that's what we're gonna do. So where's the solution? Yes, over here. So OP is perpendicular to AB, so that's why the dot product is equal to 0. That's your first step. This is your first step, very important. You need to know. Then what do we know about OP? OP is really just a line. Okay, I copy down the question first. Hold on a second. Yes, OP is just given by this formula here. Okay, lambda A plus 1 minus lambda B, correct?
Yeah.
Then you just sub in. But wait, AB, I hope by now you're very, very, very familiar with this. N minus start, N minus start. You can always break it down into its position vectors, OB minus OA. Yes?
Yeah.
Then OB is just vector B. OA is just vector A. Substitute. And since we're taking a dot product, you just distribute lor. That's exactly what I did. So lambda A dot with lambda B, sorry, with just vector B is lambda A dot B. Next one, lambda A dot with negative vector A, you get positive lambda A times dot with negative vector A. Simplify, you can factor out the negative, you're left with negative lambda A dot A. Okay, but before we simplify, let's just continue expanding the other two terms. So second term, multiply. 1 minus lambda B dot product with vector B, you get 1 minus lambda B dot B. 1 minus lambda B dot product with negative vector A, you get 1 minus lambda B dot with negative A. But the negative you can also factor out, you're left with minus 1 minus lambda B dot A. Up to this line, is it okay? These two lines? But wait, what else? You realize that B dot A is the same as A dot B, so I just swap them around. This part okay?
Yeah.
Yeah, I swap them around, everything else stay the same. Then anything else you notice? Here what you realize is that you're trying to solve for lambda. Okay, remember, you're trying to solve for lambda. Lambda equals to whatever. Here, what I do is I realize that I try to factorize and do some funny tricks. I cannot find any shortcut. So I just do the hardcore method. Expand everything out. You see bracket, you just expand. You see bracket, you just expand. So that's exactly what I did. B dot B times into 1, you get this yellow part B dot B. B dot B multiply into negative lambda, I get this part, negative lambda B dot B. Same thing with the A dot B. Oh, but take note, there's an extra minus sign. So negative with negative gives you a positive. Are these two terms okay?
Yeah.
You check first, sure?
Okay.
Sorry, let me drink some water. Yeah, okay. Ken, so all right. So now we have expanded it into all these terms equals 0. We can try to solve for lambda, which means we need to factor out the lambda. So that's exactly what I did here. Lambda. I take out the lambda, then I put bracket and I factorize. Is that okay?
Yeah.
Terms. Then the yellow terms, nothing, there's no lambda, so I just put it at the side. B dot B and minus A dot B. Then what I realized is that I can factor out a negative. Okay. Here the pattern is that I realized there's A dot A and there's B dot B. It reminds me of A square plus B square. I remember back to my Sec 2 times when I memorized A plus B bracket square is. Can you recall? A plus B bracket square is.
A square plus B square plus 2AB.
Yes. So you must remember this. By now, you cannot be hesitating. Okay, maybe I wasn't clear in my. You know this. I'm sure you know this. A square plus 2AB plus B square. So I notice here, A minus A times A, which is modulus A square. Minus B times B is like minus B square. It's off by a minus sign. So that's why I decide to factor out a negative sign to make it look more like whatever I already know. So I end up with negative A dot B plus A dot A plus B dot B minus A dot B. But what is A dot A? It's just this one. Let's just not talk about what it is first. We just rearrange and simplify. A dot A is over here. B dot B is over there. But here you got minus A dot B minus A dot B. Simplifying, you get minus 2 A dot B. I think this looks familiar, right, to our previous question. Is this part clear?
Yeah.
Okay, good. So what you realize is that actually this is the same as A minus B times A minus B. It's the same as A minus B bracket square equals to A square minus 2AB plus B square. Are we clear on that?
Yeah.
Similar, it's just a dot product version. You can verify on your own. Okay, good. Is that okay?
Yeah.
For these first three terms, then we look at the yellow color terms. B dot B minus A dot B. I'm going to simplify it. How? I am just simply factoring out a vector B. Is that okay?
Yeah.
Vector B bracket B minus A. And I just copy and paste. Okay, that's good. Now I want to solve for lambda. How? Very simple. Plus B dot sorry, I didn't put a dot product here. It should be a dot. A dot and a dot. Sorry. Important. That one cannot leave out the dot. Another dot here. Sorry. Yeah, so here the positive B dot with B minus A bring over become negative B dot B minus A. Can?
Can.
Then after that, you want to solve for lambda. How? you just have to take this, divide over. Then there wasn't a negative sign here. But now what I do next is I just multiply by -1 on both sides. So it becomes a single lambda. Is that clear?
Yeah.
I multiply already. So I get B, sorry, I left out a dot again. B dot with B minus A over A minus B dot A minus B. But the question actually requested for B minus A dot B minus A. Right? Which means that I just need to realize that denominator A minus B times A minus B, I can factor out -1 from both of them. I'll get B minus A dot B minus A times -1 times -1. What's -1 times -1?
1.
Exactly, it's just +1. So that means it will be equal and then we are done. Sorry, I left out a dot again. Ay.
So I should have done it in the previous step.
Where?
I should have done it in the A minus B dot A minus B step.
The factoring out of -1. Yeah, maybe you could have done that as well.
Okay.
Yes. But that's why I couldn't see that pattern immediately over here when I was doing it. So yeah, I just did it at the last step. It's fine. So this is just the last step about the denominator is just the same idea as 2 minus 7 bracket square is the same as 7 minus 2 square. Right? You swap them around, it becomes a negative, but you square it still become positive. Oh, okay, so question 9 done. We still got one more question. Let's go. I haven't dealt with plain questions. Oh my goodness. Can I just leave this question 10 as an exercise? Maybe you can read through the solution. Yeah. Just be careful of this squiggly line. It means a vector is a formatting error. So it's supposed to mean like, for example, RA vector on top. Okay. Yeah, I'll leave that to you. Go and read the solution on your own. Here also a bit funny. AGA is actually just A dot A. The G represents a dot product. There was a formatting error. Okay, all those G represents a dot. I'm so sorry. Anything else that you could be confused by? Here is a RA dot with RS vector. Okay.
Oh, okay.
Can yeah. Yeah, I'll leave that to you. Maybe I'll explain it next lesson. But could I just quickly go through with you some plain topics? Do you need to rush off?
I don't need.
Legit. Can I? Okay,
Yeah.
okay. Can. So that was going back to plane questions. These were all the basic stuff. Equation of a plane, finding the angle between two planes, and then you find the angle between a line and a plane, and then they tell you special property about parallel and perpendicular vectors. Parallel means that the normal vectors are parallel, which means that you have to show they are scalar multiples of each other. Perpendicular means that their dot product is equal to 0. The normals. Okay, we always focus on normal vectors. For planes, it's like the representative of the country is a normal vector. The plane is like a country, then the representative is a normal vector. Okay. Yeah, this is how I remember it. Oh, just look at normal vector. And also for this one, take note that it should be a sine, not cos. It should be a sine, not cosine. Or if you want to use cosine, which is what I usually do, I will have to draw a diagram, so I know exactly which is the angle I'm looking at. Okay, that's for acute angle between a line and a plane. Next, now we are going to move on to the few different ideas that you need to do. 8 different ideas you need to deal with in order to solve questions involving points, lines, and planes. Let's go. So first one, parallel line and plane. So here is a plane. Usually I don't draw as a single line. I draw it more 3D like this. So a plane like this. And then they tell you that this is a parallel line and plane, means that there's a plane here and then there's a line floating on top of it that's parallel to it. The key thing here is you must remember that a plane on its own is quite useless. You must focus on its normal vector here. Okay? Maybe it's nicer if I just draw it like this. Much nicer. Yes, this is the plane, and then there's a line that is on the plane, and there is a perpendicular vector, the normal vector. And what's so special about this normal vector with the line?
It's perpendicular.
Perpendicular, yes. So at first we start off with parallel, end up being perpendicular because of geometry. The line is parallel to the plane is equivalent to the line is perpendicular to the normal of the plane. 90 degrees here. Is that clear?
Yeah.
And if we know it's perpendicular, I think by now you know dot product must be equal to 0 straight away. You must remember this. Okay? Maybe I just write down for you. A dot B equals to 0, perpendicular. What else? If it's parallel, two vectors are parallel, then A equals to K times vector B. These are the two ideas you must remember. Okay?
Yeah.
Then okay, good. That is for part 1. Let's move on to part 2. Condition for a line L to lie on the plane. Lie on the plane means what? Means that you have a plane here, and then the line is directly on the plane itself. Plane pi. So you have a line L is R equals to A plus lambda D. That's a vector equation. And then you have a plane equation P is R dot N equal to P. For the line L to lie on plane pi, you must satisfy the following conditions. Dot product is 0 and A dot N equal to P. What does that mean? This part is because perpendicular. Can you see that the normal to the plane, maybe I draw the line in blue color, and then I draw a perpendicular to the plane. Do you notice that the normal and the line, they are perpendicular to each other?
Yeah.
I can move the line closer to the floor here, and then you can see it's a 90 degrees. Oh, so that's why, because they are perpendicular, I can take the direction vector, which is this guy here, which is parallel to the line. This blue, this normal and this direction vector, they will also be perpendicular. Is that clear?
Yeah.
Okay, good. That's why, because they are perpendicular, the dot product is equal to 0. That's the first condition. Okay? Next condition is A dot N equal to P. Why is that true? It's because what we are doing here is, this is equation 1, that is equation 2. If it lies on the plane, you must be able to do substitution. So that means that your R dot N equal to P must be what? A plus lambda D dot N equal to P. This must be satisfied.
Oh.
Okay. So maybe I should write down, this is a simplified version, simplified. The actual reason is because you can sub 1 into 2. Okay, so there's really just two conditions. For a line to lie on the plane pi, meaning that it is on a part of the plane, it means that they will have this perpendicular relationship between the normal and the direction vector, as well as you can substitute 1 into 2 and get a solution for lambda. But what do you realize about this equation is that you can simplify a bit more to get A plus, A dot with vector N plus lambda D dot with vector N equals to P. Can you tell me what is D dot N again?
D dot N is 0.
Is 0. So this guy is a 0. Lambda times 0 is?
Oh, 0.
So plus 0 means?
Oh, it's just A dot N.
Equals to P. Sorry, blocking already. Yeah, exactly. So that's how you get this formula. Okay? Can
P is just any number.
Yeah, it's just some number. It's part of the equation of the plane. Sorry, I haven't had practice on this. Equation of a plane. Okay, good. That is the theory part. Okay, A dot N equal to P. That is part 2. We still got 6 more points to cover. Let's go. So part 3, perpendicular line and a plane. So let's take a look at this plane here. We have a line that is sitting on the plane. Let me just draw the plane for you first. Then you have this line that's sitting on the plane. What we want to look at is the perpendicular line. We want to look at a perpendicular line and the plane. So here is the perpendicular line. You have a direction vector here, parallel to it. And what do we know? What we can straight away realize is that the normal of this plane and the direction of vector of this perpendicular line. What's so special about them?
No, parallel.
Parallel to each other. So N, vector N, the normal of the plane, is parallel to D, which is the direction vector of the line. If they are parallel, you should know straight away they must be scalar multiples. N equal to K times D. Okay?
Yeah.
Scalar multiple parallel. I think I talked about it just now, right? Here, A equals to K times B. Oh, this is for parallel line. You know slash slash means parallel, huh?
Yeah.
Okay, okay. Can, good. That is for part 3. Then we move on. Part 4. Part 4, foot of perpendicular from a given point P to a plane pi. So last lesson, I already talked about the foot of a perpendicular from a point P to a line, right? I gave you the procedure.
If
you remember, I just scroll back up.
Yeah.
Quickly show you the procedure. It was over. I scroll too much. So yeah, it was over here. Yeah, over here, right? Part 1.
Yeah.
Remember this procedure? It's
Mm.
exactly the same. It's exactly the same. Almost exactly the same.
Oh.
Let's just look at the procedure. The procedure is actually just to realize that. Let me draw the plane. I want to draw a nice little plane like this. And then you have a line. This is a line which is just sitting on the plane. And then you have another line. This is the actual line. And sorry. You have a point P. We start off with a point P. And then we are trying to find the foot of a perpendicular dropped from the point P onto the plane. In other words, you can think of it like a stone, and then you drop it down into the lake. Right? The plane is like the lake. And then you have a piece of rock or something, then you just drop it down directly into the lake. So the force of gravity will pull it downwards. And as a result, you get a foot when it hits the lake, and there's a perpendicular with the line on the plane. Can you see?
Can.
This PF will be perpendicular to this line on the plane. So that is the main idea. What you realize is that you can actually find out the equation of this line, right? Equation of this line. It will just be a point on the line, which is just the point P, the place where the rock is dropped from, the place where the location where the rock is dropped from, plus a lambda times of a direction vector. Here they chose vector n. Why? Where's vector n? Vector n is just the perpendicular of the plane. Right? What do you notice about these two lines?
It's parallel.
The normal is parallel to the line. That's why you have a lambda of vector n here. This is parallel to the line. Parallel to the line. So that's why you get the equation. And what you realize is that you want to find the coordinates of point F. So that means you can just find, which is really equivalent to finding out the point of intersection between the line and the plane, right? Yes. Mic test, can you hear me? Can. So finding out the point F is equivalent to finding out the point of intersection between the line and the plane. So how do you find a point of intersection between two mathematical objects?
You equate to each other.
Exactly. Point of intersection. Just do substitution. So how do you do substitution? Let's take a look. Here we got the equation of the plane, so that's just your vector r. Here you got r dot n equal to p. Anything common?
The n, the other r.
N is common. Sorry, I didn't see that, but the r is common. Okay, so we can substitute the r in. So OP plus lambda n can go inside the r. That's exactly what we have over here. Vector OP plus lambda n, the equation of the line, for some n, for some lambda, then it will give us the OF. For a particular value of lambda, this will become your vector OF. Yeah, so that's what we will get. OP plus lambda n dot with the vector n equal to p. Then after that, you can just expand everything out and then solve for lambda. After you solve for lambda, what can you do? You can substitute it back inside the equation of the line. Then you can solve for OF, which will be your foot of the perpendicular. Can? So it's the same thing. It's just substitution. And then you find your lambda and then you substitute in. It's just that this time you have to be a bit more creative. What you're supposed to do is you're supposed to find out the equation of the line, and then you just substitute this equation inside the R. All right. Yeah, and I explained already how you get the line. Just a point on the line, which is the point P, it will be given. Then the lambda times of a direction vector. In this case, they chose the vector n because it is parallel to the line. N being the direction vector, the perpendicular of the plane. Can point 4?
Okay.
Okay, next, point 5, reflection of a point P in a plane pi. So here is a plane pi. You have a point P, it's reflected to the point Q. So when you do reflection, it's exactly the same as reflection about online. Okay, you still have to identify your magic triangle. Dun, dun, dun. And always pick what point? What point do you pick?
The O.
Very good. Always pick the origin point O. Then after that, you just draw your duck feet. And it's the same procedure. Huh? So OF is equals to, sorry, handwriting. Vector OF is, yeah, the ratio will always be 1:1, right? Because it's the reflection midpoint.
Yeah.
Yes. So that's why you get 1 times of OQ plus 1 times of OP divided by 1 plus 1, which is 2. We already know OP, we already know OQ. So all we need to do is to solve for OF, I think. Oh, no, other way around. We know OF from the previous part. From part 4, we can find out what is OF. So for part 5, we need to recycle the information. You need to use OF, which we already know. And then OQ is the unknown one. We need to solve for OQ. Solve for OQ. Can?
Can.
Yeah, just ratio theorem. Okay, part 5 done. Next, just make sure you draw the magic triangle and the duck feet. I'll draw a duck for you. Okay, duck. Okay, I don't know how to draw. Something like that. Must have a duck feet. Okay, can. Part 6, distance from a point P to a plane. So this one, they tell you to use dot product. Can you see that there is a normal vector over here? There's a normal vector over, let's say I'm going to cut the word already. Here.
Yeah.
Oh, wait, they actually drew it for you. They drew it over here. Oh, so actually they draw it, so I don't need to draw anymore. This is your normal vector to the plane. Maybe if I just make it a bit more 3D, I'll draw in a plane for you. Then there's a line on the plane. That's the normal of the plane. And then you have a QP. You want to find the distance from a point P to a plane. What you need to do is to figure out a point Q first, which is really just any point on the plane. Okay, how do you find out a point on the plane? By trial and error. So for example, if let's say you got a plane that is this equation, how do you find out a point that is on the plane? You can trial and error.
Oh, I just start in the R value.
Pick a good value of x, y, z, so that when you take the dot product with 1, 2, 3, you get 7. How about 2 copies of 3? That's 2 times 3, which is 6. How much more do I need to get 7?
1.
1, right? So how about 1 times 1? Then here put a 0. Does it work?
Can.
So check. So R dot 1, 2, 3 will become 102 dot with 1, 2, 3, which is 1 times 1 plus 0 times 2 plus 2 times 3, which is 1 plus 0 plus 6, which is a 7. What a coincidence, it is 7. Therefore, we conclude that 102 is a point on plane. Is one example of a point on the plane. Can?
Oh.
Yeah, then that's what they are talking about when they say trial and error. Do this. Just make a guess. Okay, then after you find this point Q, you can find out the vector QP. What is QP again? What minus what?
OP minus OQ.
Exactly, good. So you find your QP first. You'll know what is P, and you also found out an example of a Q. Then you can find your QP. Then you just need to take the dot product. Can you see that this is really just Michael Jackson here, and then this is the floor.
Yeah.
The sun is over here. The sun. Maybe I draw a torchlight for you. Ding, 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 a torchlight. So they cast a shadow here. Then this is your length of projection. Maybe I draw pink color. So this is the length of projection. You can find out that length in that sense. However, actually, right, there is another strategy. Which is that if you already found out the foot over here, maybe I'll just call this method 2. Because I don't usually use this method. I don't use method 2. I usually use method 1. point number 6, method number 1. It is similar to whatever I discussed with the line, distance from a point to a line. Basically, you can find out the foot F from point P to the plane. Right? That's from point number 4, right? You find OF. Then after that, step 2, oh, I have more space, I can just. Then step 2, you can just find out the vector PAF, which is OF minus OP. Then step 3, you just find, for me, PF. You can combine step 2 and 3 into one line if you want. Find the modulus. Right? I think this is easier. No? Just find the vector PF, then take the modulus.
Yeah.
Alternative is to take dot product, which is arguably a little bit challenging to visualize. Okay, they are the same. I prefer method 1 because you can use it in from a point to a line as well. So it's really just the same thing. 4, 5, and 6 is really just the same thing, but just that 4 is a little bit different. Okay. The same thing as finding out the relationship between a point to a line. Okay, that is 4, 5, and 6, but we are not done yet. There's still 2 more. Let's go on to look at the last 2. Length of projection of a PQ onto a plane. What does that mean? It means that you have Michael Jackson here, and then the sun is on top. Maybe I draw a torchlight, easier to draw. Okay, you have a torchlight on top and it casts a shadow. You want to find the length of this shadow. Length of projection. How? Very simple. You just need to use cross product. How come length of projection use cross product? I thought length of projection is dot product. How come this one they tell me to use cross product?
Yeah, I also.
Because you cannot just memorize. You have to understand that here what we are doing is the torchlight is actually not over here, because we are making use of sorry, okay, maybe I should start from the beginning. Okay, so first we begin with a plane. And then this is, I hope you can visualize this as floating on top of the plane. My plane is in the background. Or maybe I'll just use gray color. Would it be easier? Yeah, gray color to tell you is the background. So now you got this line that is on the plane, and then you have a normal to the plane. We can only work with the normal of the plane. And then they tell you you have a vector PQ. You want to find length of projection. What do you realize? The vector A, the PQ or QP is the same thing, is over here, and the vector N is over here. Do you notice that this is like vector A and this is vector B? So if you actually use dot product and length of projection, what you will end up finding is this length here. It's actually part 8, this length here. It's actually part 8 here. This is the length of projection. The torchlight will be over here. Okay. However, what we are doing now, right? When I draw the torchlight over here, it's wrong. The torchlight is never on top for this plane question. It should be on the side. Yeah. Okay, it's on the side. So you'll cast a shadow here, but then in that case, what would this length actually be? This length would actually be the perpendicular distance. Right?
Yeah.
Let me just redraw it in a different way. Let's say I have a vector A, I have a vector, here's a point B, this is vector B. And then I want to cast a shadow over here. This guy would actually be A dot B divided by modulus B. Whereas this guy here, the perpendicular distance, it would be A cross B divided by modulus of B. Does that make sense?
Yeah.
So I think if you just turn the diagram around, it will be clearer now. Can you see? The bottom now becomes the cross product, the vertical becomes the dot product. Maybe I should have color coded it. Wait, give me a moment. I'll just change this bottom part into a red color. And then I'll change this part into the pink color. Can?
Can.
Can yeah, so this one, I'll just place this here, but then I will make a duplicate and turn it around. And put it here. Then you can have a reference. Oop, oop. Sorry, wrong diagram. This one with this one. Okay?
Okay.
Yeah. So yeah, just use dot product and cross product. Here they gave you the final form already, PQ dot with n and PQ cross with n, the unit vector. That's why they put a cap. And why did they put down a sine theta here? Honestly, I'm a bit confused. Yeah, that's actually correct. It's just making use of Tuakaso. Sine theta is just opposite over hypotenuse, so it will be the red color zigzag divided by the hypotenuse, which is the length of PQ. Does that make sense?
Yeah.
Opposite hypotenuse. Then you can just make this zigzag the subject. Just multiply the PQ over. That's how you get this formula here. Okay. Likewise for the length of projection one. You can also realize that cosine theta is adjacent over hypotenuse, which means that it's the pink color zigzag divided by the hypotenuse PQ, which is just the length of vector PQ. And then you can do the same thing, multiply over. Then pink color zigzag will be cosine theta multiplied by the modulus of PQ, vector PQ. Can?
Okay.
Okay, we have gone through all of the theory and formulas that you need to solve questions. Now we can solve some questions. It is 11:41. Let me just go through. I see maybe we can do the basic worksheet. Let me see. Where was the worksheet? Homework number 1. The examples worksheet. Or should I give it to you as a practice, as a homework?
Can.
Okay. Let me just cross out some questions. Question 37 you cannot do. Question 36 is also outside of the syllabus already. 3 planes one. Sorry. Yeah. Let me see any other things. Oh, right. Line of intersection between 2 planes. I didn't mention this. Basically, when you got 2 planes that intersect, right, you just need to use your GC. Use GC. Solve.
Oh.
Yeah. Maybe I'll demonstrate this, question 36. So let's see. Question 36. Could you make sure you have the question with you, because I'll be changing to the GC soon.
Oh, okay.
Yeah, can make sure you have the PDF open. So I'm just gonna solve it over here. Let's do part 1. Find the point of intersection of the plane blah blah and the line blah blah. So very simple. Whenever you got a plane in the Cartesian form, it is not useful. Please always convert into the normal form. What do you call that? The scalar product form. So the procedure is, first you must start from Cartesian form, the XYZ, and then you convert into the vector form. Wait, hold on. Is there a more direct way? Let me think a little bit. Yes, there is. Just use a formula to convert it into a scalar product form. So I think I misspoke here. The scalar product form straight away. How do we do that? What we realize is that you can rewrite this as XYZ. Dot product with 3, 6, minus 5. Agree?
Yeah.
Then what is XYZ? It's just a generic vector R. So it's R dot 3, 6, minus 5. Then there we go. That's our scalar product form. So here they tell you they have a point of intersection. You have vector R, here also vector R. What do you think you want to do? Let's call this equation 1. Let's call this equation 2.
Just like equate to each other.
Exactly. So that's what we're gonna do. So minus 2, 1, 1 plus lambda times of 0, 1, 1 equals to, no, not equal. This guy is the R, you dot product with 3, 6, minus 5. Equals to 0. Can?
Can.
Okay, then you just need to solve for lambda. Let's quickly do that. So minus 2 plus 0, 1 plus lambda, 1 plus lambda. Dot product with 3, 6, minus 5 equals to 0. Multiply out, I get negative. Okay, I'll just write down the working. Can?
Can.
You get negative 6 plus 6 plus 6 lambda minus 5 minus 5 lambda equals 0. Here I realize 6 minus 5 become 1 lambda. Then minus 6 plus 6 cancel. You're left with minus 5. Bring the minus 5 over, get a positive 5. That's my answer. Okay?
Okay.
Lambda equal to 5, not done yet. We need to solve for point of intersection. What do we do?
Use the GC.
Huh? No. No. You got lambda already. Solving for point of intersection. GC is for part 2.
Just sub in the value of lambda.
Exactly. So you sub in the value of lambda into whichever one you want. Okay, actually, no, not whichever one. Use number 2, the equation of the line. So therefore, R is equal to minus 211 plus 5 times 011. Multiply out, I get minus 2 plus 0, 1 plus 5, 1 plus 5. 1 plus 5 times 1, 6. 1 plus 5 times 1, 6. Minus 2 plus 5 times 0, negative 2. Okay?
Okay.
So this is the coordinates of the point. Okay, that's for part 1. Part 2 is totally unrelated to part 1. Let's move on to part 2. For part 2, find a vector equation of the line of intersection of the 2 planes. This is the first plane, that's the second plane. How we do it is we use a GC. So what you need to do is to make sure that you align the equations are x plus y plus 2z, invisible 1 here, invisible 1 there, equals to a 9. Second equation, 2x plus 4y minus 3z equals to 1. 2, 4 minus 3, 1, 1, 2. This is 2 equations in 3 unknowns. So you go to your GC. Let me just change to my GC real quick. Hold on a second. Yeah. Okay. And then I right click. And then I share this screen. Is it clear?
Yeah, can see.
Okay, I should get rid of this binomial PDF. Anyways, let's just go through how to get the solution. So yeah, you start from the home page, you click on APPS. Okay, then you go down to poly simultaneous tool. Enter, go to simultaneous equation solver, choose 2 equations in 3 unknowns, 2, 3 like this. Okay? Press next. Then you just key in accordingly. We already got a 1, 1, 2, 1x plus 1y plus 2z equals to 9. Then next is 2x plus 4y minus 3, so negative 3 equals to 1. Take note, by the way, here I wrote down negative 3. I use this negative sign. Do not use minus. You use minus, it doesn't work. Must use negative. Okay, must use negative. Okay, then you press stop. What do you get? You get a bunch of things. Let me just copy this down. So what I have is, sorry, give me some time to copy this down. 35 over 2 minus 11 over 2 x3, negative 7 over 2 plus 7 over 2 x3, and then the last one says x3. You have a 1, 2, 3. Okay, let me just change my screen back to my iPad so I can annotate. I hope you are doing this on your GC as well while I'm doing it.
My GC no battery.
Oh my goodness. You better charge it. You need to use it.
On cable.
You better go and buy it. Oh my goodness. How can you be prepared for A-levels without a GC?
Yeah, it just ran out of battery. I bought on Shopee already. I'm waiting.
Okay. Good. You can buy second-hand from Carousel quite cheap. But anyways, you already bought it. Doesn't matter.
Okay.
So let's take a look. This is the equation. Here's what we got. You need to translate it into our language. Here we use x, y, z. The GC uses x1, x2, x3. So here x3, what do you think it represents?
The z.
Exactly. So that's why we're gonna replace the x3 with z. So z, z, and z. What do you think 1, 2, and 3 here represents?
Like x, y, and z.
Exactly. So that's what we're gonna get. X, y, z equal, equal, equal. They use colon, but it's actually just an equal sign. So now we got 3 equations already. What we can realize is the z here is what we call a free parameter or free variable. If you learn before biology, you will learn about degrees of freedom, right? When you're doing chi-square test.
Yeah.
It's the same idea. It's the same idea. It's a free parameter. Here, only 2 degrees of freedom. Here, it's only 1 degree of freedom. There's only one guy that's free. But not so important. What's more important is to rewrite it as the equation of a line. Because 2 planes will intersect in a line, right? I think you can visualize they intersect at a line here. So this is actually an equation of the line. How can we convert it into an equation of the line? We can treat this z as if it's a lambda. Okay, so here, we can think of it like this. Z equals z is really just the same as z equals to 1z plus 0. 0 plus 1 times z. Can you see the pattern?
Oh, so z is lambda.
Yes, correct. Z is lambda. So that means that all that we need to do now is to collect them into a vector form like this, x, y, z. Then the first component is 35 over 2. I'm running out of space. 11 over 2z, but we don't use z. Replace z with lambda. So we get 11 over 2 lambda minus 17 over 2 plus 7 over 2 lambda. And then the last guy is just a lambda. Okay?
Oh, okay.
Then you just rewrite it. Now, constants is, I'm going to write it slanted, so I hope you still understand. It is 0. Add on lambda times of what? Negative 11 over 2, 7 over 2, 1. Is that clear? And this is just a generic vector R.
Yeah.
Okay, good. I'll send you the updated file later. Don't do the last 2 questions. Yeah, so that is, sorry, sorry, I have somebody just called me. I need to pause for 10 seconds.
Okay.
Sorry. Hello, sorry. Yeah, I'm back.
Okay.
Yeah, so anyways, that is the equation of the straight line, lambda and limit of real numbers. Just use GC only, very easy.
So as long as I see it's 2 planes, I just use GC.
Correct. Yes. So intersection between 2 planes. Sorry, I think my lecture notes never talk about it. But basically it is still inside your syllabus. Let's take a look at the syllabus. Here they got talk about relationship between 2 planes. I forgot to mention this. I talk about parallel and perpendicular, but I forgot to mention the last one, when they intersect in a line. And 3 cases. 3 cases. Parallel, perpendicular, or intersect. I just went through. This is question 36. Parallel and perpendicular, maybe another example. I'm not sure if I have it. Yeah, here 35. You can try on your own. I'll just start from the bottom. Give you the rest. I think you can do already. You just have to yeah. I think I'm gonna leave it to you to do, but I'll give you some hints. I'll start from the bottom. Okay, I expect you to do all the questions from question 23 until question 35. Okay, you can redo question 36. So for question 35, vector equation of the line of intersection of 2 planes. Easy. It's the same as question 36 part 2. Just use GC. Just use GC. Use GC sub Z with lambda. Just follow the procedure over here. Okay. The procedure here. Can. Okay, good. I'll leave that to you. 34. Find the acute angle between the planes blah blah, and blah blah. So here when you find the acute angle between the planes, can you visualize? I draw for you nice plane. This one you must be able to visualize on your own. Oops. Can you see?
Oh, yeah.
So what's the conclusion? If you want to find the angle between planes, it's actually the angle between
The two normals.
equivalent to angle between normals. So how do you get the normal here? R dot
R dot N. So the two
N is
negative 1, 2 is the normal.
exactly. That's my first normal. How about this one? A bit more complicated. How to convert?
Must convert back to the vector form.
So dot product. Always remember dot product between two things. What are the two things? Equal 3.
The
X,
X, Y, Z.
X, Y, Z on the left. How about the other one?
Then 3, negative 2, 6.
So what do you conclude? How do you get this is the normal already, right? What's a bigger conclusion? Faster conclusion? Just read off the coordinates. Just read the coefficients. Can you see? 3 minus 2, 6. That's it. That's your normal. Okay, faster way lah, but of course show the working. Convert into the what we call the scalar product form. Convert the two equations. Maybe you should also label it. Call this pi 1 dot dot, pi 2 dot dot. Copy down the equation. Pi 1 dot dot this one, pi 2 dot dot this one, and then you simplify into the scalar product form. So now that you got the two normals, what do you do with the two normals? Find the angle between them. Acute angle means you need to do what?
A modulus.
Modulus, very good. Cosine theta equals to modulus of a dot b over mod a mod b. This is your vector A, that's your vector B, or your N1 and N2. Can? 34 easy, okay, good. 33, find the acute angle between the lines. Finding the angle between the line is the same as finding angle between
the normals.
Normal. Line got normal, man.
The direction vector and the normal.
Got normal, man. Oh wait, yeah, correct. Here is the plane. Okay, so let's just draw a diagram. So is the angle, is it going to be cosine theta or sine theta?
Sine.
Sine. Okay, so let's see. This is direction vector. In this case, it will be 4, 3, 2 lah. I'll leave that to you to figure out. Then you have the right angled triangle here. This angle here is your 90 minus theta. That guy is your theta. You're trying to solve for theta. To solve. Then I think you can see that the normal is here. When you have direction, you have normal. You take the dot product. If you want, you can just draw the diagram and then conclude that, if you take dot product between D and N, and then you using the cosine theta formula, you will get this angle, 90 minus theta. But in order to find the other angle, you need to convert it. You need to convert from 90 minus theta into theta. Just 180 minus 90 minus theta minus 90. Because you got triangle. I think it's better to not remember the sign. Remember the cosine. Draw the triangle. This is what you'll get after you use the cosine theta. You'll get that angle from using cosine. Okay? Easier to remember. So it's not normal and normal, it's direction and normal. Direction and normal. Okay, very good. That's question 33 done. I'll leave that to you. Question 32. Find the point of intersection of the line and the plane. How?
Just sub in the R.
Just sub in, exactly. So you take this equation, sub in. After you sub in, what do you get? What's your objective? You're trying to solve for?
Solve for lambda.
Sub in, solve lambda. Then, after you find lambda, what do you?
I sub lambda back into the equation.
Let's call this number 2, let's call this number 1. Which one? 1 or 2?
1.
Number 1, because lambda only appears in 1, I think it's quite obvious. Yeah, okay, good. So you know already. Just do it, practice. 31, find the position vector of the foot of the perpendicular from the point P to the plane. How? How? What's the procedure?
Find the PF.
PF, okay.
Then the
Really?
PF.
Oh, okay, PF, yes. And what's missing in my diagram?
The direction, the normal.
Direction vector. What else? The normal. Yes, very good. No space, so I'll just write it outside. Maybe I'll just make my diagram a little bit longer. So my plane is sitting out. My normal is sitting inside my plane. Doesn't matter lah, huh? Okay, then PF. You told me PF.
So the so it's parallel to PF.
It's parallel to vector n.
So A cross B is 0.
Oh, you use the cross product is equal to 0. That actually works. That actually works. But that's not what I was teaching you. You can do this. Better not. Okay, can I just pause another 1 minute because I got a call incoming. Oh my goodness.
Okay, sure.
1 minute, sorry. I'll go think about it. I'll go look at the notes. Hello.
Yeah.
Hi Don. I need to do something, so I will be away for 10 minutes. Will that be okay with you?
Oh, sure.
Can yeah, I'll come back in 10 minutes. Okay?
Can.
Can all right. Sorry.
Oh, no problem.
Okay, I'm sorry. I'll go away first. Mic test, mic test. Mic test, mic test.
Yeah, Ken.
Sorry. Hi, I am back. Can I continue?
Yeah, Ken.
Can I? Okay, good. So let's take a look. What do we want to find? Find the foot of the perpendicular. So let's look at the notes. What did we go through just now? Finding the foot of a perpendicular. So part 4, what is the procedure?
The A plus lambda B for some lambda.
Yes. So in this case, it's actually OP plus lambda n, right? See? Yeah. Okay. Over here, it's just OP plus lambda n. N is a vector that is the normal of the plane. It is parallel to the line PF. Okay.
Okay.
Then after that, you got the line already, just sub in. Then you can solve for lambda. Then after you solve for lambda already, you substitute back into the equation of the line, you're able to solve for OF.
Oh.
Okay.
Okay.
Anything to clarify?
No. Just
No,
I know how to do this method. Yeah. Okay, I try later.
Okay. Yeah. So let's just figure out what's the line L first. The line L, in this case line PF, is actually just R equals to OP, which is 1 1 minus 2, or 1 negative 1 2, plus lambda times of the direction vector. In this case is N. What's N? Can you see straight away?
-3.
3 1 negative 3, right? So now that you have the line and you have the plane equation here, R dot whatever equal minus 61, you can just substitute in. Sub LPF, just call it LPF into, I'll call this 1, maybe I'll call this 2. Instead of LPF, I'll just call it 2. Sub 2 into 1. Solve for lambda. Then after that, sub lambda into 1, and you are able to solve for OF. Okay, make sense? Because point F lies on the, sorry, no. Let me think a little bit. Does it make sense? I realize I draw my diagram wrongly already. No wonder you're confused. Shouldn't be the line. This should be the line. This should be the direction vector. And it's parallel to the vector N. Okay? Yeah, then you just have to substitute in the lambda into the equation of the line, and you will be able to solve for this point F. Okay, that's a 31. Then after that, find the distance from point P to the plane. I think I prefer just finding out what is vector PF, OF minus OP. Then you take the modulus. Can? Yeah, don't need to use the dot product. I think that's a bit confusing. Okay. Just modulus. Okay, next one. Question 30. Find the distance from the point P to the plane. Same procedure. Same procedure. Okay, I don't go through question 30. Then question 29. Find the position vector of the foot of the perpendicular from the point P to the plane. Find also position vector of the point of reflection of the point P in the plane. So this one is asking you to find foot. So it's the same procedure again. Can? Just different numbers. But here they also want an extra point of reflection. How? You must remember duck feet, duck bone. Here's the foot. Here's the P. Here's the reflection. Let's just call it point P. Let's just call it R. R for reflection. Then do you want to? What point do you want to use over here?
Use O.
Okay, good. Use a point O. Then after that, by the way, maybe this point O may not lie on the plane now. It may be outside of the plane. Especially when here is not 0, you should know straight away it's not. The origin does not lie on the plane. But you can still use the same idea. Then just use ratio theorem. Okay. I think you already understand how to do this. I won't talk too much about it. Question 29, ratio theorem. Then question 28, vector. Oh, by the way, what's a ratio?
1 to 1.
1:1. Okay, that's the key idea. Okay, moving on. Question 28. Now, vector equation of the plane pi is given by this fellow. And find a vector equation of the plane pi in scalar product form. What scalar product form? R dot n equals to some constant p. Scalar product form. How do you get n? Can you remember?
It's
n is
cross product of two direction vectors.
So what are my two direction vectors?
The 1, 2, 3 and 2, 1, -1.
Very good. That's my D1, direction 1, and my direction 2. Okay, that is cross a scalar product form. Then how do you okay. This one, should I demonstrate? I think I should. So let's just cross them. So 1, 2, 3 cross with 2, 1, -1. What do you get? See, cover up the first row, then left minus right, down minus up. So -2
-3.
And here, second row must have negative open bracket, negative square bracket first, then down minus up. Cover up row 2, down minus up.
So -1 -6.
Okay, last row, row 3, cover up row 3, down minus up.
So it's 1 -4.
Very good. So now you get -5, +7, and -3. That is your n. You don't need to find unit vector, don't need to divide by the length. This is good enough. Then you can just figure out what is the equation of the line. r dot negative 5, 7, negative 3 equals to p. How do you find out what is the value of p?
Like sub in the R.
Sub in the r, which is a point on the plane. Can you tell me what's a line on a point on the plane?
The negative 3, 4, 1.
Very good. This is a point on the plane. Just like a point on the line, right? When you got the L, you got R equals to A plus lambda B. This A here is a point on the plane. That B there is the direction vector. For equation of a plane, it's the same thing. It's just that we extend it with an extra mu times d2. Extra direction. Because it's a plane, extra dimension. So you just need to sub in negative 3, 4, 1 here, dot with the negative 5, 7, minus 3, and you can solve for p, implying that p equals to minus 3 times minus 5, that's a 15, 4 times 7, that's a 28, 1 times negative 3, that's a minus 3. Double negative gives a positive, that's why it's a 15. Then type in a calculator. 15 plus 28 minus 3, you get 40, right? Is that correct?
Yeah.
So therefore P is 40. You found your scalar product equation. How to find Cartesian equation?
Sub in the x, y, z.
Yes. Okay. This one I leave it to you. Sub R with x, y, z. Okay, then you get your three equations. Get three equations. X equals something, y equals something, z equals something. Can?
Okay.
That is question 28. Let's move on. Question 27. Find a vector equation of the plane in scalar product form and Cartesian equation form of the plane that passes through the points A, B, and C. Okay, so here the key is to draw a picture. Draw a picture and you will understand. What is direction vector? Direction vector is essentially a vector which is parallel to the plane. But here they already gave us 2 points which are actually on the plane. So can you see can you construct two direction vectors for me? How about I give you one, AB. Does AB work?
Yeah.
And of course, because it's on a plane, it will be parallel to the plane. How about BC?
Also can.
Also can, yes. How about AC?
Also can.
Also can. So it doesn't matter. Just pick two vectors. Then you know how to find vector AB? What minus what?
It's OB minus OA.
Likewise for AC is?
OC minus OA.
Okay, so you're able to find those two vectors already. Then after that, how do you find the scalar product form? R dot n equal to P. How do you find n?
Cross product of
of the two vectors you found. In this case, AB cross with AC. Right? You get this resulting vector. Is that correct?
Yeah.
Can so yeah, then you can get your normal. But wait, that's not enough because you still need to find your P. So you just have to substitute the vector R with A or with B or with C. Doesn't matter. Either way, you will always get back the same answer. You can try. A dot with the normal, B dot with the normal, C dot with the normal. Okay, that's good. You found your P, then you can replace your P with whatever you found. Whatever you found. This one, sub with either A or B or C. Just pick one. Save time. You only need one to get your value of P. P is a constant. Okay, so after you find your scalar product form, what do you need to do? Cartesian form. How to find Cartesian form?
Just sub in the x, y, z.
Okay, can. Yeah. Sub. Not enough. Still need to conclude. The conclusion is you get three equations. X equals something, Y equals something, Z equals something. Okay, easy, right? Good. Then 26, find a vector equation. It should get easier and easier because I'm going backwards. Find a vector equation of the plane in scalar product form that passes through the point blah blah and perpendicular to this guy. So let's see. What does it mean? It means that I have a vector, a plane like this, and then it's perpendicular to I, 4K, 2K. Sorry, this should not be a K again. This should be J. That's a typo. Wow, lucky I checked. Okay. So this is really just saying 1, 4, 2 lah. Is that clear?
Yeah.
So that means it's perpendicular to this guy. That means you have a perpendicular n, which is 142. And then you have a point. So I think by now you know it should be r dot n equals to p. You need to find out what's n. You found already. You need to find out what is p. How? How to find p? Sub in r with
3, 1, -1.
Okay, then n with
the 142.
142, correct. Then you take the dot product, you will get your p. And then you're done. Can? Can, good. That's question 26. Let's move on. Question 25. Find a vector equation of the plane in the form of blah, 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 vector form, containing the lines L1 and L2. So it means what? It means you have a picture, must draw a picture. Here is L1, there is L2. You have a 1, 2, -1 plus lambda 1, 2, -3. It means that there is a vector, direction vector, that is 1, 2, -3 here, parallel to L1. There's another direction vector here that is -1, 1, -2. That's parallel to L2. How do you find the normal?
The cross product.
Exactly, just find the cross product. Okay, maybe I just move it back and I think you get it already. To find the normal, you just take the cross product of two vectors parallel to plane. So in this case, the two vectors also are not parallel to each other. They are parallel to the plane, but they're not parallel to each other. I think that's clear, right? The blue vector here and the blue vector there, they are not parallel. So in this case, you're just gonna take D1 cross with D2. The blue cross with the blue. Maybe I'll label here D1 and that one is D2. And then so on and so forth. I think you will know how to find. But vector equation of the plane in the form this guy, right? So actually what I just did to find the normal is to find scalar product. So actually that's not very correct. It's correct if you're finding scalar product, but here they didn't ask for scalar product. They asked for this form, which is the vector form. Vector form requires D and E. So actually, right, it's a lot simpler.
So just leave it there.
Yes, correct. You don't need to change anything. Just copy down the D and the E. They are the two directions already. This is testing you on the concept of how to construct equation of a plane. It requires a point A that lies on the plane, and it requires two direction vectors. Both of them are parallel to the plane itself, but they themselves are not parallel to each other. Then what is a point on the plane?
They got same eh? The 1, 2, -1.
Exactly, because they are containing the line. So actually my diagram is incomplete. I should extend my line a bit. And since both of them are 1, 2, -1, it means that my lines actually intersect at this coordinates 1, 2, -1. And that's my point A. Also my point A I remove. It should actually be here. Then I can just put in 1, 2, -1. That's all. Easy. I solved for you already. Can skip. 25 done. Next. Question 24. Find a vector equation of the plane in the form blah 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 passing through the points A, B, C. Can I leave this to you?
Yeah, can.
A, B, and C. Just figure out what do you need to solve this. Question 23. Find a vector equation of the plane in the form blah 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 passing through the point blah and parallel to the vectors blah and blah. So ijk is 1, 1, 1. 2i minus j minus 3 is 2 minus 1 minus 3. Yeah. So it must be a plane. It passes through this point, and it is parallel to those two vectors. So if I can just draw two parallel vectors like this, that's sitting on the plane. Those are the two vectors. That's 1, 1, and that guy is 2 minus 1 minus 3. How to find the vector form? Go figure it out. Okay, it's quite obvious. This one should be the easiest. And that's all. Okay. In addition, can I just request for you to do another homework for me? It's homework number 3. Did I send you homework number 3?
Yes.
Yes. So if I could just bring out homework number 3, hold on a second. Homework number 3 is homework number 2 I already went through already. So just do homework number 3. Is this guy. Got time or not? Can do all or not?
Can.
You can do all already. Oh.
Yeah.
Just make sure that when you see the questions involving 3 planes, don't do them. It's no longer in your syllabus.
Oh,
Like
okay.
here, between 3 planes on, you don't do it anymore. Okay. Yeah, so that's your homework. Question 23 onwards from homework 1, from examples worksheet, and all of the questions in this question 18 until question 18. Can? Okay, got 1 week. 加油, go.
Can. Okay.
And that's all for today.
Okay.